Welcome everybody. This is Jay, and I want to build on our last video where we went and added polynomials or went over how to combine like terms. Now, a little bit more in addition to that is when we combine like terms, it's important that we're able to classify polynomials. And what I mean by that is recognize whether or not the terms are like terms. And the reason this is because if they're not like terms, we cannot combine further. We cannot simplify by adding or subtracting. For example, look at this first polynomial, 2t to the fourth power plus 7. Notice the first term has the variable t in it. The second term has only the number 7. These are not like terms. Because they're not like terms, they can't be simplified. The polynomial has to be left as it is. And it would be a binomial because it has two terms in it, 2t to the fourth and then plus 7. And also keep in mind a binomial would be considered a polynomial as well. Now let's look at another example. In this example, we see the highest exponent is 2, so the degree of the polynomial is 2. Now look at the terms. Are they like terms or are they not like terms? Well, if you look at all three terms, they all have the variable e, and they all are raised to the second power. Because of this, they're called like terms. And because they're like terms, we can simplify the polynomial by adding the terms and combining them. So we will do that. If we add 3 plus 5, we get 8, and then 8 minus 9 gives us negative 1, and we would just write negative 1e to the second power, which is the same as negative e to the second power. So that's how we do combine like terms in a polynomial when there are like terms. But it's very important to be able to distinguish and make sure that the terms are like before we combine them. Okay, next I'd like to show you how we evaluate a polynomial. Now keep in mind, evaluating a polynomial is not the same as solving a polynomial. When we evaluate a polynomial, we're just given a value for the variable, and we just plug that value in to the polynomial. For example, this polynomial is 5h to the fourth power minus 3h squared plus 4h plus 7. Plug in h equals negative 3. So to do that, everywhere we see a h in the polynomial, we put a minus 3. So we get 5 times negative 3 to the fourth minus 3 times negative 3 squared plus 4 times negative 3 plus 7. Now after we've substituted h equal negative 3, it's important that we be careful with our signs, and we may want to use a calculator or at least double check our work for our signs carefully. When we raise minus 3 to the fourth power, we should get a positive number, and it will be negative 3 times negative 3 times negative 3 times negative 3, and we'll get positive 81. So we have 5 times 81. When we raise negative 3 to the squared, or to the second power, we get a positive 9. So we have minus 3 times 9 plus 4 times negative 3 plus 7. At this point, we've applied the exponents, being extra careful with the signs, and now all we have to do is multiply the terms. So 5 times 81, we get 405. Minus 3 times 9 is minus 27. 4 times negative 3 is negative 12, and then plus 7. Notice when we multiply terms with different signs, the answer is always negative. For example, 4 times negative 3. 4 is positive, 3 is negative. When we multiply them, they have different signs, so we get a negative 12. that might help you with remembering your sign rules. Now we just add the terms. So 405 minus 27 minus 12 plus 7, and we get our final answer of 373.